All right, so in this project, we have been so lucky to have two wonderful master students with us on this project, Ulrik and Leander, along with great EVB mentors, Annika and Torstein. They are all here today. And now we'll hear more about their work to design a solar-powered cold storage for the greenhouse. So again, just a quick reminder to mute yourselves, and there will be time for questions after. Leander and Ulrik, please take it away.
Yes, thank you, Elisa. Yeah, so we had planned a short speech from Vincent, but he couldn't be here today. But I think you pretty much covered it, Elisa.
Yes. Thank you for the introduction, Elisa. So me and Leander are really excited to present our work on the cold storage system that we have contributed and developed for Trax Ghana. So for the next couple of slides, we're going to walk you through the technical setup and also some agricultural context and the key milestones of the project. We will briefly touch on the economic aspects, but the main focus of this presentation will be on the system design, implementation, and also future potential. So yes, I'm going to start with the project timeline. So during the fall of 2024, me and Leander conducted the project work, but the master thesis and the project officially started in January this year, followed by finalizing the initial design for the cold storage in February. While doing this, we had a procurement process running in parallel from January to April, ensuring that all components and also logistics were in place, making sure that the supplier also was trustworthy. This process was conducted from Norway. Then, in the end of February, we were supposed to conduct a field visit to Trax Ghana in Bolgatanga in northern Ghana to align the project and the design with the local conditions and also exchange knowledge and experiences. Due to unforeseen circumstances, the field trip was ultimately not carried out, which was really sad for all the parts of the project. But we agreed on a supplier, and the construction began in mid-July and was completed in the end of July. So in August, finally, the cold storage is up and running, and we have been completing post-completion testing and to verify that the system is performing as expected and is ready for its use.
Yes, so as Ulrik mentioned, the field trip to Ghana was unfortunately cancelled, which was very sad for the two of us and for everyone who was supposed to go. But our main empathy lies with the people who are directly involved in that in Ghana. So yeah, it was sad not to go, but there are other things as well. Yeah, so we had planned our master's thesis a bit around being able to go down there and exchange culture and knowledge. And the knowledge would mainly be in operating and understanding the cold storage and the connecting microgrid. This was unfortunately not done, but I hope that our master thesis can provide some insight into how it's operated. And yeah, we were also supposed to collect some data and do some on-site assessments, but we had to change it, and our master thesis now focuses a bit more on the economical and environmental aspects rather than on-site assessments. However, there was one good thing that came out of it, and that was that it allowed us to properly consider the suppliers, because if we had gone down there in February and we wanted to start the construction while being there, then we would have made some probably rash decisions. So yeah, the cancellation allowed us to take some time to consider a lot of different suppliers. You do the next one, Ulrik.
Yep. So I'm gonna just give you a brief presentation of the property and give you some context about the area, the climate. So the Trax facility itself consists of 3 primary buildings that serve both educational and agricultural functions. So this, I have made an illustration down on the right side, and these buildings include a farm building, a youth empowerment center, and a greenhouse. So our plan the whole way was to install the cold storage in an empty space in the farm building. So some climate considerations includes that the region experiences 2 distinct seasons that influence both the agricultural cycles, but also solar energy generation. So the rainy season that spans from May to October is characterized by lower temperatures and more frequent rainfall. But in contrast, the dry season, which is from November to April, experiences more high temperatures, clear sunny conditions, which is more favorable for solar energy production, but then can create more harsh climate for the operation of the cold storage. So as per today, there is one existing greenhouse producing approximately 20 kilograms of vegetables per week, which follows a 6-month cycle where we have 3 months for growth and 3 months for harvest. And this results then in an annual production of around 500 kilograms of produce. So understanding these seasonal dynamics are important for understanding how the energy system and also the cold storage should support the agriculture operations.
Yes, as the basis for our thesis, we have assumed that there are 3 additional greenhouses which will be built, and I think that's in the works as well, or I hope it is. So with the 3 additional greenhouses, that would mean a total yield of 2,064 kilograms of bell peppers on average. And there are other vegetables that can be grown as well, but this was our basis because that's what we had the most data on. Yeah, and as Ulrik said, they will follow a 6-month production cycle. But in addition to producing more vegetables with the additional greenhouses, it also allows for a diversity of grown crops. So you can follow the market and see which vegetables are most in demand for the different seasons and for the different months. So you can plan ahead and then see which one is most in demand and then demands the highest price. Yeah, so that's a part of the aim of the cold storage. And it also helps reduce the food loss, because at least during the dry season, the temperatures can be as high as 46 degrees. So you can imagine what happens to the vegetables if they're left in that heat. So yeah, so the cold storage aims to both improve the prices of the different vegetables and also improve the food loss.
Yes, I'm just gonna walk you through the off-grid energy system of Trax Ghana. And last year, the original PV system consisted of 30 solar modules giving a total capacity of 8.55 kilowatt peak capacity. And per December 2024, there was a system upgrade with 12 new models, all rated at 565 watt peak, increasing the total capacity to 15.5 kilowatt peak. And all of these modules are installed on the farm building roof. Also, there was completed a battery storage upgrade with 8 new lithium-ion units, increasing the total storage capacity to 40 kilowatt hours of storage. And also a brand new inverter was installed. On the left side, you can see a single line diagram of the energy system in Trax, Ghana, and the upgrades done in December of 2024 laid the foundation for installing the cold storage facility without doing any other installations and upgrades.
During the fall of last year and then the beginning of this year, so January and February, we completed an initial design of the cold storage in collaboration with Vincent and the people at the Youth Empowerment Center. So to facilitate for the 4 greenhouses, we decided on a cold storage, which is 3 by 3 by 2.5 meters. And also to accommodate for different vegetable storage, which have different optimal storage conditions, we decided to split the cold storage into 2 separate rooms. So, for example, the left room could hold 1 degree and a relative humidity of 90%, and the other one could hold 10 degrees with a humidity of 80%. And it also is easier to take into consideration the ethylene production from vegetables. And I don't know how much you know about that, but as a rule of thumb, you shouldn't store green vegetables with red ones, because the red ones produce ethylene and the green ones are sensitive to it. So our solution was to split it into 2 rooms. And this was supposed to be cooled by an indirect refrigeration system using the natural refrigerant R290, which is propane, and then a water-based solution as the refrigerant which circulates within the cold storage, because propane is highly flammable, so it has to stay outside in a flame or fireproof container. Yeah, and we also dimensioned the compressor to be 0.5 kilowatts, so it's not a big refrigeration capacity or refrigeration demand. But yeah, this was our initial design, and we'll come back to what it ended up with, which was part of some of the challenges of this project.
So a big part of this project, even though it really didn't have too much to do with our actually master thesis, a lot of time and also an important part was the procurement process. So during the procurement phase, we engaged in negotiations and also a lot of design discussions with especially 2 different suppliers. So after careful consideration, we chose a supplier from located in Accra, the capital in Ghana, named Smart Bee Technology, primarily due to their competitive price and also the trust we developed during the process. But however, the initial negotiations were not without challenges. Of course, when we're completing this process from Norway, there was a degree of insecurity, both regarding their pricing, but also their promises, which really raised the question, how do we take the word for it? We developed a connection and also a good solution with the supplier. So this experience really highlighted the importance of building supplier relationship based on transparency, but also accountability, which I think is really important in this type of projects.
Yes, while we were talking to Smart BE Tech, we developed a solution for the cold storage and the refrigeration system together, and that meant we couldn't implement everything we wanted to. So we had to compromise quite a bit on the refrigeration system and the capacity of the compressors. Because we wanted the indirect system, which only would require one compressor, but that was quite difficult to do in Ghana. So the final design is 2 separate split-type air conditioning units. So in reality, the 2 storage rooms, they operate separately. So they could be 2 different cold storages. And we also wanted to use the natural refrigerant of propane, which you can see have a global warming potential of 20. And the baseline of the global warming potential is CO2. So propane is 20 times worse than CO2 if it's emitted to the environment. But that was, it's not easy to get pure propane in Ghana, and is also difficult and expensive to provide maintenance to the compressor and to the system using natural refrigerants. So the supplier gave us 2 main options, which was R410A and R404A. And we chose R410A because although it's much worse than propane, it's still a lot better than R404A. And as I mentioned, the maintenance is quite difficult in Bolgatanga because of the dusty environment and also because of the heat. So to have the warranty for the refrigeration system, frequent maintenance has to be done. So it's about monthly maintenance, which over a couple of years would be very expensive. So the solution we came up with is to have 2 local engineers shadow the maintenance team from Smart BE Tech, and then have them take over the regular maintenance in a year's time, which is much cheaper and time efficient. Yes, so we wanted to have an emphasis on being environmentally friendly, but we quickly realized when talking to the suppliers and to the people in Ghana that it seemed a bit too early to do this project using natural refrigerants such as propane or ammonia. And as you can see on the right, there is a table which is from the Kigali Amendment, which aims to phase out HFCs throughout the entire world. So the table is specifically for countries like Ghana, where you freeze the consumption of HFCs, which are environmentally harmful refrigerants. So you aim to freeze it in 2024, and then not until 2029 do you have to reduce the consumption by 10%. So right now there isn't a clear reduction in the usage of HFCs, but it will come. So we've said to each other that we're a few years too early, unfortunately. And we did a total equivalent warming impact on the different refrigerants, which takes into consideration the leakage and refilling of the system, and also the regeneration of the refrigerant. And the R404A and R410A are not looking good in comparison to R290. But I think that we made the best out of the situation by choosing R410A. Yeah, and since you don't have to phase out the HFCs yet, there's also a lack of supply for natural refrigerant compressors and maintenance equipment. Yeah, as Ulrich said at the start, the cold storage testing has begun in August, and there was a couple of issues at the start with temperature and the likes. So it's looked for a while like the cold storage drained the battery way too much, so it couldn't operate continuously. However, after a couple of weeks of adjusting the temperature and the system setting in, you can see here a screenshot from 6:47 a.m. And here the battery is at 97%, and that's after running throughout the night and the day before. So I think we can say that it works and it can actually deliver what we aim to do.
Yeah, that's great news. So we were a bit nervous in the start, but we got some update from Vincent, the project director at Trax Ghana earlier today, and he says things are still stable, and that's really good news. So yeah, I'm going to talk a bit about future works. I think that is also a important aspect of this meaningful master and the project, because there is always a possibility to improve the solution and to learn about what could be done better. So looking ahead, we will have to monitor the cold storage and better understand how the environmental and also the season impacts the performance. And especially right now there is rainy season, and see how temperature but also solar availability can affect both the battery and also the performance of the cold storage during nighttime. So we will keep talking with Vincent and monitor the AC units and see how also the defrosting behavior performs, and start having a real data collection but also modeling, which can be used for other projects, especially within Engineers Without Borders for future projects that can really draw advantage for this project. And also, as Leander mentioned, we have established a maintenance program and routines, and this is also going to be important due to the harsh climate of northern Ghana, and we will have to make sure that this training of the two personnel goes smooth, but also have knowledge sharing with people working at the farm, and this can help ensure long-term sustainability for the cold storage. And also, as Leander mentioned, in the future we could look at exploring the use of natural refrigerants to reduce the environmental impact, and as Leander mentioned, to align with the future regulations and standards in Ghana. I think this is important because the numbers Leander showed with potential leakage has this really impacts on global warming. Yeah, so I just want to conclude this presentation by thanking Elisa, Torsten, and Annika, and of course Vincent, for having a lot of conversations and backing us up and helping us with this project. And it's so satisfying to see that and have this project actually finalized with the cold storage built and working as planned. So yeah, we want to thank you for that. So here's some recent pictures from the cold storage, and you can see that they started harvesting and using the cold storage. So that's fantastic to see. Maybe we can open up for some Q&A. Also,
yeah,
here
absolutely.
you can also see
yeah.
some pictures from the manufacturing process, and yeah.
That's great. First of all, I would like to thank you. Thank you so much for your really, really great work and all your hard efforts. It hasn't been easy, but it's finally done. We did it, and great work and contribution. And also shout out to Torstein and Annika, the wonderful mentors, for following up and always being there with your valuable input. And sadly, internet gods are not with us today, so Vincent is not able to log on. The internet in Ghana is very bad. So he was supposed to say something, but on his behalf, I'll also say thank you. So now we can open the floor for questions. Please just unmute yourselves or raise your hand. Yes, please, Heidi.
Yes, first, thanks a lot for a great presentation. And as I've followed a bit from the side, it's all this that you couldn't go out in the field and everything. It really looks like it's you've been able to have contact with Vincent and his team and people on the ground to figure out the best solutions. I was just wondering about this natural refrigeration, this R2D2, no, sorry, that you will look into the possibilities, but would that need any reconstructions, or is it more like if it's available and yeah, did you understand? Yeah,
I understood. So it is possible to switch to a natural refrigerant, which is emission-free, but it would require some reconstruction, and the compressor has to be changed. But right now there isn't like or for some years there isn't a requirement to change to the natural refrigerant. So it shouldn't be an issue for this cold storage throughout its lifetime. But of course, it's something you would want to do for the environment. But that would require an extra cost. Yes. I hope that answered your question.
Yeah, thank you. And I second what you're saying, and also want to stress that due to demand issues, it's just wasn't possible to do in northern Ghana. Bolgatanga is far away from a big city, and the airport is about 3 hours away by car. So yeah, but it was considered carefully.
Yeah, and it also highlights some of the important parts of knowledge sharing, because it's like this for a lot of the parts of the world, that the natural refrigerants aren't yet widespread, so they have to resort to the refrigerants that we were using 20, 30, 40 years ago, which should be phased out by now. But yeah, the development isn't as far everywhere in the world. So yeah, it's important to share our knowledge and to aid in the transition.
Absolutely, very important aspect. And I think, making the most of it, it's the impact this cold storage will have for Trax Ghana is tremendous. We are also currently looking to scale up this project and procure 3 additional greenhouses. Each greenhouse would be 300 square meters, producing a lot more vegetables and securing year-round production. And so this cold storage really opens possibilities that I think they couldn't dream of 3 years ago when we built the greenhouse. So allowing the project to grow as well, and the aim with the additional greenhouses is to provide vocational training for a lot more girls, right? Because this is a very poor area, a lot of parental poverty, child marriages is a huge problem here, teenage pregnancies, girls drop out of school. There's a 50% dropout rate amongst girls in this region. Please, Jose, you have a question.
Yeah, thank you for the interesting presentation. I'd like to ask if you consider it complementing the storage in the batteries, thermal storage with PCMs or something like that. That's one question. The other question is, did you focus mainly in the cooling system, or also in the construction of the chamber itself, with considering the choice of the thermal insulation and so on?
Yeah, so the first part was thermal storage, if that could be implemented as well. Correct?
Yes.
Yeah. We haven't looked into that because there were already batteries and solar panels, but it's in the case of cooling place through thermal storage, then that could be possible. Yes, we just haven't considered it an option due to the existing infrastructure. And then the second part was how we considered the insulation material. Or yeah,
yes,
so
if you have done any kind of thermal simulation to choose which thickness of the insulation, kind of the insulation, and so on. Yeah.
So we, during the project work last fall, we designed the cold storage with insulation, and we used one of the most common materials. I think it was polyurethane. And we did all our calculation based on the assumption that we would use this. So that means calculating the transmission load and the infiltration load based on using that insulation and with a recommended standard thickness of 10 centimeters, which is from literature. But this spring, the suppliers, they have their own type of insulation, which is PIR boards, which is the pre-manufactured insulation. And luckily for us, this insulation had an even better thermal conductivity than we had calculated with. So the solution they have was better than what we were imagining. But when you have a thickness of approximately 10 centimeters and a relatively low thermal conductivity, I think we initially calculated with 0.036. Then it's small changes in the temperature and doesn't affect it a huge amount. But yeah, we didn't choose this exact insulation, but yeah, there aren't too many differences when it comes to the thermal conductivity, at least from what we experienced. I hope that answered. Yeah.
Yeah, thank you.
Thank you for that question. Any follow-up questions or other things? Comments are also welcome. Mohammed, please.
Yes, thank you very much for the presentation. My own question is, I want to know if this, the construction of this cold storage, how it's being constructed. It's whether do you use a corrugated steel sheet in between bricks, because for us here that you construct it in a local way, or did you get this cold storage imported and being assembled in Ghana? So I just want to know how the construction gets along. And also the other question is, I want to know what is the total load capacity for this compressor, and what amount of load the solar panel will, what amount of load this cold storage will also carry. Because I saw you have 10 kilowatt inverter and 15 kilowatt capacity of solar panel. And also, what is the load capacity for this particular cold storage?
Yes, that's a great question, and something we didn't talk a lot about. So firstly, the construction. It was prefabricated components, so everything was already pre-made and then shipped to northern Ghana. And maybe Ulrich or Elisa can help me, but I don't completely remember if they were produced in Ghana or shipped from another country.
I don't. Maybe they were shipped earlier, but at the time of procurement process, they had everything in storage. So I'm not really sure. I don't know about you, Lisa.
Yeah, that's correct. So the local supplier had construction materials in stock. So what was shipped to Ghana in this regard for this project were the compressors, right?
Yeah.
So this local supplier, Smart BE Tech, they have a partner company in the Netherlands, so that's where it came from.
Yeah, thank you. And yeah, there are vapor insulation barriers as well inside to prevent the moisture from leaking out. But this was handled by the construction team. Yeah, and as to the refrigeration capacity, I didn't mention that earlier, but the compressors are over-dimensioned for our need. So the greenhouses can be vastly expanded to and it still would have more than sufficient capacity. But the reason why we couldn't go with a smaller one was because of the supply. We only needed maximum 1 kilowatt compressor, but it was difficult to procure. So the two compressors that we have both have a minimum capacity of 1.2 kilowatts, so 2.4 in total. But they run on an on-off cycle, so it's not a continuous drainage of the power from the compressor. You set a desired temperature at, for example, 1 degree or 5 degrees, and then a maximum desired temperature. So maybe it ranges from 3 to 7 degrees. And while it's between 3 and 7, then the compressor is completely off. So yeah, that's so there are a bit over-dimensioned. Yeah, did that help, or was there more to the question?
Yeah, thank you very much. It helps a lot.
Okay, thank you.
And also, our master thesis will be published on the Engineer Without Borders website. So we have also conducted some simulations of the cold storage load on the energy system, and if you want, you could also have a look there. Yeah, but also me and Leander are now also engineers without borders. So in the future, for similar projects, just don't hesitate reaching out to us.
Yeah, and there's also a step-by-step guide, if you want to call it, on how to complete the calculations of the refrigeration loads with the formulas, and yeah.
Thank you. We have another question. Please go ahead.
Yeah, thanks. This is Oscar Alskan, Engineers Without Borders, Denmark chapter. I was able to join a bit late, but thanks for the part which I was with you. And probably I missed that, but the contact details of you, Ulrich, and then the team. Will you share that? Will it be shared, or is it already shared to reach out for further inputs?
We can put contact details in the chat.
Brilliant. I appreciate that.
No worries.
Thank you.
And thanks for joining from Denmark. That's great.
Yeah, that's a pleasure. We are working on a similar project, and so your lessons learned are valuable for us, and that's why I would be very happy to stay in touch with you guys. We got lots of stuff to learn from your experience in Ghana.
Don't hesitate to reach out.
Will do so. I need your contact details though.
Wonderful. Thank you so much. I think I also shared the thesis actually with Christian Grøn. So you can also reach out to him at EVB Denmark. But for sure, we'll put contact details in the chat. Any other questions or comments? Doesn't quite look like there are.
I can say it was really nice to work with you. Thank you a lot. It was my first time and I was a bit nervous, but it was really great. Amazing students, you guys, Leander and Ulrich, and Torstein, who has done that before a couple of times. So thanks a lot. this was great.
Yeah, thank you so much. Yeah. And I think I can speak for both me and Leander when saying that you being mentors also, I think, will inspire us to apply for similar positions in the future and continue to share our knowledge on a later stage. Yeah, thank you so much, Annika and Torstein.
And thank you.
It's really been great. Yeah. Torstein, please.
Oh, no, nothing.
All right. Also have to thank everyone for listening in. Also want to say that we have another presentation as well of another Meaningful Masters project. It's in 2 weeks, the 4th of September, at the same time, 3 o'clock. And it's about designing a community center in Zimbabwe. However, this will be in Norwegian. And my colleague Heidi put the link in the chat just now. On that note, thank you, everyone. Wish you all a great afternoon and hope to see you in 2 weeks.
Thank you.
Thank you for listening.
Thank you.
Thank you.
Thank you.
Thank you.